Here in number 34, we're asked to evaluate the arc sine of negative 0.73 in radians using the calculator, and we want to find all solutions over the interval negative infinity to positive infinity, approximating to 2 decimal places of accuracy. So we're going to start in our calculator, making sure the mode is in radians, because we're told in 34 to use radian mode. And then second sine is the arc sine, and negative 0.73 is going to give us the principal value. Remember, the calculator can only see the principal value. That's where the inverse passes the vertical line test. For sine's inverse graph, that principal value is from quadrant 4. So in my circle, I know that my principal value just came from quadrant 4, and it's a negative angle. I'm going to round that to 2 decimal places, so negative 0.82 is the principal value. Now, to find the solutions, we want to find the positive coterminal angles 1 revolution around the circle. So all students take calculus. Sine is negative in quadrant 3. So we're going to take this angle and reflect it into quadrant 3. Half the circle is pi, and my principal value is negative. So to get into quadrant 3, I'm going to need to do pi minus the principal value, because minus a negative is a plus, and that will move my angle counterclockwise into quadrant 3. So in the calculator, we evaluate pi minus this principal value, and that's 3.96. So my quadrant 1 angle, or sorry, quadrant 3 rather, is 3.96. And to represent all of the possible solutions, we're going to tack on plus or minus k times the period in radians, which for sine is 2 pi. So I could keep lapping around my circle over and over again in the positive or negative direction, and I'll always land here with a coterminal angle that was at 3.96. Okay, then to find our quadrant 4 answer, because sine is negative in quadrant 4, we're going to take 2 pi, that's the whole circle, and we're going to add the principal value, because plus a minus is a minus, and that'll take us then clockwise to get into quadrant 4. So in the calculator, we'll evaluate 2 pi plus the principal value, and that's 5.46. That's the quadrant 4 angle, and then plus or minus k times the period gives an expression representing all of the possible answers that have that same terminal side in quadrant 4. So our solution is both of these expressions to represent all of the possibilities in that interval from negative infinity to positive infinity. And then in number 35, we're asked to evaluate the arc cosine of negative 0.85 in degrees. And the principal values for a negative cosine are going to come from quadrant 2. And that means these are, or this is going to result in an obtuse angle. Then all students take calculus. Right, we can see that cosine is also negative in quadrant 3. And so we're going to need to reflect that obtuse angle from the principal value into quadrant 3 in degrees. So 360 for the whole circle. We're coming clockwise, so we're going to subtract to get into quadrant 3. So this solution will be 360 minus our principal value from quadrant 2. So in the calculator, we're going to go to the mode and make sure we're in degrees. And then we're going to evaluate the arc cosine of negative 0.85. And that's our principal value, 148.21. Then we take 360 minus that principal value to get our second solution, 211.788, so 0.79. So our first solution, the principal value, is 148.21 degrees, plus or minus k times the period in degrees, which would be 360. And then our quadrant 3 solution was 211.79 degrees, plus or minus k times the period of cosine, which is 360 in degrees. So these two expressions together will represent all of the possible solutions in degrees over the interval negative infinity to infinity. Okay, then lastly is the arctangent of 3.95 in radians. And tangent's positive principal values will come from quadrant 1. So we'll have a positive acute angle in quadrant 1. Then all students take calculus, and we can see that tangent is also positive in quadrant 3. So in radians, that's going to be pi plus the principal value to get into quadrant 3. Okay, when we look at our calculator, we're going to start by changing our mode to radians and then evaluating the arctangent of 3.95 to get 1.32. That's our principal value. And then if you notice, the period of tangent is half the circle. So to get from my principal value to my second solution, I add pi. But if I add another pi, I get right back again to the terminal side of my principal value, and so on and so on and so on. So I really don't have to evaluate to find the decimal approximation for my quadrant 3 angle, since the period will allow me to run right into it. So 1.32 plus or minus k times the period of tangent in radians is pi. That expression will represent by itself all of the possible solutions, since the period of tangent is half that of sine and cosine.